Thank you everyone for coming. I want to start off the presentation by thanking all of the organizers of this camp for doing such a great job. Thank you to Holy Cross for hosting us. This has been awesome as always. You guys are here to be slapped around a little bit, I imagine. You're looking for someone to convince you why there are no more excuses to not write tests. And we'll get right into it. My name is Erich Beyrent. I'm a senior Drupal developer at Behat. We make software for researcher compliance and tracking in the areas of safety. So we joke around that we help prevent the zombie apocalypse by making sure researchers who are working with radiological and biological and chemical things are safe and they're trained to use all their stuff. So it's a really good thing. According to my Drupal profile, I've been a member of the community for 12 and a half years. I first started on Drupal 4.5 and threw it away, and then came back on 4.7 and then threw that away, and then started making my living on Drupal 5. All my network stuff is up there. None of that really matters. All right, so who here has ever written a unit test before? Okay, who here has ever written a kernel test before? Okay, who here has ever written a browser or an integration test or a Behat test? All right. So there's a good mix. So let me start off by saying that I graduated with my computer science degree in 2000, and my first job was working for a company that made software for newspaper systems. And I was a member of the QA test team, and the software was written in Java, and it had Java client, and it had a Sybase server backend with a lot of Perl. And every month we'd come out with a new version, and it was my job to execute a test plan manually. And we had three customers, and the applications were configured completely differently. And so some of our test plans were like 30 pages long. Some of our test plans were like 120 pages long. And that's what I did every single day, every single week, manually. And yeah, we found some bugs, but it's horrible. So we're going to talk about why we write automated tests. We're going to talk about the types of automated tests that Drupal 8 supports. And of those, we're going to talk specifically about unit tests, kernel tests, and what Drupal calls functional tests, which are really integration tests. So browser tests, JavaScript tests, and then we'll talk about behavioral tests, specifically Behat. So why do we write the automated tests? As I was saying, doing the manual test is generally cheaper, okay, because there's not a lot of upfront effort in laying things out and making sure things work. You don't have to set up the infrastructure. You don't have to, there's not a lot you have to set up except for writing the actual documents that you're supposed to follow, the procedures you're supposed to follow. It is boring AF. Sorry, I did that for 4.5 years and lost those years of my life. It's time consuming for projects that iterate. So if you're writing a project and you're continuously releasing new features, new functionality, and you got to repeat that month after month or sprint after sprint after sprint, it is time consuming. And worst of all, manual testing is hard to make repeatable. It's very difficult to get two people to test the exact same way in the exact same steps, no matter how well you document it. There's always variations. And the documentation itself is very extensive. If you want to make sure your testing is complete and thorough as possible, and then you have the upkeep on that. So Guillermo Raj, he wrote Socket.io, and he's got some other cool stuff. He came out with this tweet not too long ago, where he said, "Write tests, not too many, mostly integration." And we're going to talk about all those things, especially the mostly integration part. So we write tests to better discover the bugs during our local development, right? Who here has ever given a piece of software to a client and had them come back and say, this is broken? Yeah. I'll better raise your hands or you're lying. Automated tests give developers the confidence to iterate and to make changes because you know that you're going to catch those bugs. And some tests are self-documenting, specifically Behat tests, and we'll talk about that in a little bit. So first we'll get started with unit tests. So there's a couple of you who have written unit tests. The purpose of the unit tests is to test individual methods as discrete units. Okay, so that means that by their very nature, unit tests are what are called solitary tests. We use what are called test doubles or mocks to control the behavior of the related components. So when you've got this method and it's got some inputs and it's got some underlying things that it relies on, we can set up test doubles or mocks of those underlying components or those inputs to control the behavior of what our test, what that method actually does. And unit tests are super fast to run in PHPUnit. And Drupal 8 supports PHPUnit out of the box. And Core has lots of unit tests, and there's lots of examples. And even better, there are great documentation pages. So one of the things that they start writing tests or they start writing a module in Drupal 8, and it's great, build out your functionality, and then your boss or your coworker says, hey, that's great, do you have any tests? And the first thing you think in your mind is, shit, how do I write a test? I've never done that before, right? Who's ever come up with that? You've been put in a position where you've got to write a test and you say, I've never done that before, right? So I work at Behat now. Before I came to Behat, I was working at Pearson Education, and we had this legacy application that was PHP. The code was like 10 years old. And it was PHP 5.1 or something like that. And we were rewriting the code base and making it all object-oriented, and we're basing it off of Symfony and off of Zend. And we decided that every single piece of code we were going to write was going to have a unit test. And so for the last for 4 or 5 years before I came to Behat, I was writing tons and tons of unit tests. Right? So now I come to Behat, and we're starting to rewrite our application in Drupal 8 and starting to port our modules over. And that fear pops in your mind. Crap, how do I write a unit test in Drupal? It really is the same. If you've ever written a unit test for PHP for something else, writing it for Drupal is really no different. So the first thing you got to know is where to put your tests. So in your module, you're going to have a test subdirectory, and it's going to have an SRC, and then it's going to have a unit directory. And then because of that directory, your unit tests are going to have that same namespace. Okay, so Drupal /test / the name of your module / unit. Okay. Each of your tests, your unit tests, are going to have some annotations. This covers default class specifies the name of the class that you're testing. It's pretty simple. And that group is a way for you to group a bunch of tests. Sometimes you can do it the name of your module. Sometimes you can also go and tag it to, say, a Jira ticket or a Trello card or whatever, so that when you make a change, let's say you're working on a bug fix for some feature and you've got some card and you go and you fix it and then you write a test to prove, you don't want to go run through the whole test suite, you just want to run that one test, you can specify that tag. And you can specify multiple groups as well. So it gives you the functionality, the flexibility to do those things. And on your individual test methods, you're going to use the @covers annotation to specify the class method being tested. So take a look at this piece of code here. We've got a constructor, and we've got a method that uses some of the instance properties of the class. Who can tell me what's wrong with this code?
You're not using dependency injection?
Who said that? All right. We're not using dependency injection.
I recognize it. I can't do it.
You're gonna see in the year and a half that I've been writing Drupal 8 code, I've seen a lot of this. And this should be a red flag whenever you see some code that's got a method and it's pulling stuff directly out of Drupal service. Because we're not using dependency injection, you can't control the behaviors of the HTTP client or log or config by mocking it, right? You're going to get in there whatever Drupal passes in, and that's bad. Because if you look at the Get Astronomy picture of the day, you can see at the bottom there, This code is trying to make a request to some URI. If we don't mock this and control the behavior of that HTTP client object, we can't test what happens when this method connects to the service, what happens when it doesn't connect to the service, what happens when it gets a bad response, right? We want to be able to test all of that, right? So unit testing depends on dependency injection. That's where you laugh politely. We're all awake, right? Okay, so if we were to write this properly, we would, of course, document our parameters in our doc block, and we would pass in those dependencies through the constructor as we've got there. Okay, so now that I'm passing these into my constructor, now in my later unit tests, I can create mock instances of the client and the logger and the config objects to control their behavior. Okay, so what are mocks? Mocks are doubles. They're fakes. They're used to simulate some object to control its behavior. There are lots of ways that Drupal 8 supports mocks. Natively through PHPUnit, you can call the getMockBuilder method on a given class, and that will create a mock. You can use the Prophecy library, which is also in Drupal 8, supported natively in Drupal 8, and you call the prophesize. Or you can use Mockery and pull that into your composer.json, pull in that dependency, and then you can use that if you want. Or maybe there's another library for creating test doubles that you prefer. You can use that too. Just pull it in as a dependency. Running PHPUnit itself is very easy. PHPUnit itself gets pulled in via Composer, so it ends up being in the vendor bin directory of your install. So we run it from the web directory, you go up a level to php.unit, and we do the -c flag, and you pass it, and this XML file which sets up some stuff, environment variables, things like that. You can just use the core dist1 unless you have specific reasons to override it. You say that you want to use the unit test suite, and then the group would be the name of your group, and that group corresponds to anything that you've tagged with the group annotation. All right, so what does this actually look like? Get out of this and pull into this. Is that too small, guys? Yeah. Let's see. Does anybody know a quick thing? Apple Plus?
I don't think it works.
It doesn't work.
No.
Pinch and zoom.
Pinch and zoom?
Yeah. Go into the anything.
Pinch and zoom. Huh. No. Ah, ding, 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 ding.
There you go, now we can see it.
Okay. That's really big.
Unit tests, one letter at a time.
Yeah. Okay. So you all will be very proud of me. Last week, I took my son to the skate park for a skate session and was there for about 6 hours. And I said, oh, crap, I got Drupal Camp next week. I better come up with a presentation. And in order to demonstrate all the different test things that you can do in Drupal, I decided I was just going to write my own module to demonstrate this. So that's what I did. So back in 2004, I started working for Plymouth State University and had experimented with Drupal and couldn't figure out what the hell taxonomy was. I didn't even understand the word taxonomy. And so I went to WordPress and I built this blog. And I was also fascinated with NASA. And so NASA's got this service called Astronomy Picture of the Day, where every single day they throw up an image, some astrological image with some credits, and then an explanation about what you're looking at. And I said, you know, that would be really, really cool to display in my WordPress site. So I wrote a WordPress plugin. And that was my first contribution ever to an open source project. Flash forward to here, this still works as a great example for unit testing. So I've got some code here. There's a client service that goes out and talks to NASA's endpoint and pulls in some data. And I've got a custom block, which I'll also pinch and zoom. It's just a block plugin, which uses the APOD client to display the astronomy picture of the day. Okay, really simple concept. So we're going to test these things discretely. The client itself gets an instance of the Guzzle HTTP client to make its requests. So this class is basically just a thin wrap around it. It's got a protected URL. That's where it's going to go out to make its calls. It's also got some associated configuration. There's an API key that you have to sign up with NASA. They give you an API key. We pass this in through configuration. And then there's this public method here, get astronomy picture of the day. So that goes, it builds the query string, passes in the API key, calls the request method, and gets a response, and then handles that. So that's what we're going to be testing. So if we look at our client test here, and I don't mean this presentation to be a deep dive on how to write unit tests, more than there are great examples that you can follow. It took me about 5 hours to write this whole entire thing of code, the module and all the tests. It's really that simple. So there really aren't any more excuses. So what we're going to do here is we're going to call this setup method. So backing up, we have our unit test here. We're in the proper namespace, and we're going to extend unit test case. Okay, so unit test case is a helper class that Drupal 8 provides, and sets up a whole bunch of nice things for you to be able to use. You can write other classes that extend unit test case to provide your own specific behaviors, and then you can extend that instead. Unit tests will automatically call the setup method on every single method that you're testing. And so this is just going to set up some stuff. So the first thing we're going to do is we're going to create a mock instance of the Guzzle HTTP client. Okay, so I'm using the prophecy library. I'm creating a mock object, and I'm telling it it's going to use this interface, the specific interface. Same thing with the logger and the configuration. So I'm setting up a config here to return some bogus API key. It doesn't, because we're doing this in isolation, the requests aren't actually going to go out to NASA, so it doesn't matter what the API key is. Okay? And we're going to set up the mock config, so when you call the apod.api config off the config factory, we're going to return back our mock config object. So now we're going to test the constructor. All my tests, my unit tests, always test the constructor just to make sure that nothing breaks. And so it's really simple. You call the object that you're trying to test, you pass in your mocks, and then you make sure what you got back was an instance of the class that you expected. Okay, pretty simple. So now, what are the cases that we want to test on this astronomy picture of the day? We want to test that what happens when we get a success message from NASA, what happens when we get a failure, right? So in order to do that, here's what we're going to do. I have this helper method called getMockResponse, where I'm just setting up this fake JSON object with the properties that I expect to get back from the service. So when you call their service, you get back this JSON object that's got copyright and date, the explanation, the images, all that kind of stuff. So when we're testing the success, I set up a new response, a new successful response, status code 200, the content type is going to be JSON, and I'm going to return back this JSON bit, which I'm getting right up here. And I'm going to say that whenever I make a request through the mock HTTP client, I'm going to return this response. Okay? Now, we also have to know that in the client, in this handle response bit, that if we get a successful status code back from our response, we're going to JSON decode it, and we're going to return that. If there's an error, we're going to log it. Okay? So we need to be able to set that kind of stuff up in our test. Here we're saying that because we're testing a success method here, we're going to say that the logger shouldn't be calling any warnings. We shouldn't see any error messages, and we shouldn't see any info messages in the log. None of those things should get called. Okay? We're going to create our new client, and then we're going to call the get astronomy picture of the day. We're going to assert that we got a standard class back, and then it has some attributes. Okay? We're going to do the same thing with our failures. Okay? So we're going to simulate these kind of responses, 403, 404, 500, 598. And for each one of those, we're going to set up error conditions. and error responses. And we're going to expect that if there's an error, the logger should be called one time. And the warning should not be called, and info should not be called, right? So we're going to test all those things. How do we go and run this? Again, I'm sorry, you can't see that at all. Is that better? Yeah. Okay, and I know you can't see the left edge. How's that? Okay, so we're in the web directory. We're calling PHPUnit. We're passing in the XML file out of core for its config. We're going to use the unit test suite and the group, and we're going to run this. And we're going to run this. And we're going to run this. There we go. I had one of those oh crap moments yesterday. I did the thing that you should never do. I upgraded my operating system right before the presentation, and it wiped out everything. And I was crapping my pants last night, putting things back together. So I tested it a couple times to make sure that everything worked. If I was running in Docker containers, I would have been fine, right? All right, so you can see that this ran 3 tests, and there were 23 assertions, and everything passed. What happens if we go and we change something? We had asserted that on a success, let me go back up to my success. We asserted that we were going to have a title attribute on our return object, and that it was going to equal foo. So let's just go down to the bottom and let's change this. Now let's go run the test again. What do you think is going to happen? Going to get a fail. And we did get a fail, and it tells you where it failed and it tells you why it failed. It got something back that it didn't expect. Okay? So if we ever were to go and muck around with the responses and change those responses, and we forget to update the unit test is going to fail and remind us, hey bud, you forgot to do something here. Go fix it. Okay?
As long as you remember to run the test.
Well, so we'll get into that in a minute, right? We'll get into that later. Let's get back to this stuff. Okay, so that's unit tests. Kernel tests are like unit tests on crack. Okay, kernel tests are sociable, meaning that they do run with dependencies. They do run with things in the background. They run with a minimal Drupal environment, and we write kernel tests when the unit tests are too hard to write, meaning there are too many dependencies to mock or too many things to simulate, or it's just very difficult or it's too time consuming. You write a kernel test. Kernel tests have access to the database and the file system. You have to, when you go and you run one of these, it creates a minimal Drupal environment, so then you then have to go and install, manually tell it which modules need to run in order to satisfy your test. And kernel tests are slower than unit tests because they still have to bootstrap Drupal. They don't run in isolation like the unit tests. Unit tests don't need anything but the code. Kernel tests need a little bit of back-end stuff. Kernel tests, again, the system is very similar. So instead of putting it in the source unit, you put it in source kernel, and then your namespace will match that structure. In order for these to run, you have to set up an environment variable called simpletestdb, and you set that up to whatever database you want to run. You can either do that here on this command line, or going back to that this bit, oh crap, sorry, where it says the core PHPUnit.xml.dist, you can copy that, make it your own, and then set the environment variable in that XML file if you want. I don't recommend modifying the core one. That's bad. You tell it to use the kernel test suite, and again, we use the groups, so we're going to tell it to run the ones in our module. So what is our kernel test going to do? Our kernel test is going to install block. It's going to install system, user, and our module. And it's going to do some basic things here, install the user entity schema. And what we want to test here is that when I enable my module, a block actually gets created. So that's what this test enabling APOD module creates block does. I get an instance of the block manager. I tell what block ID I'm looking for, and I assert that, yes, the block manager does have that definition. And again, that's because this specific code is creating a block via the block plugin. Okay? So that's one thing we can do. Another thing we can do is we can actually test the behavior of the block by mocking the behavior of the client itself. So what I want to say here is that when I get no response, or I get an error response from my APOD client, I want to not show the block. The block is going to be set to empty. So this is my actual block plugin. And in the block plugin, it has a dependency on the APOD client that's getting passed in through the constructor. Okay? And that's, again, so we can control the behavior of that during testing. So here in the build method of my block, and again, you can tell it's a block plugin because it's got this block annotation bit up here. Because it is we're calling the build method, I call my client, and if the client returns null because there was an error, I'm just going to return an empty array. Otherwise, I'm going to return my render arrays where I do some stuff with the image and the text and all that other stuff. So again, testing that's exactly what we're going to do here. We're going to set up a condition here where our mock client will return null. I'm then going to, in the container that's local to this test, I'm going to set apod.client service to be my mock. So you can muck around with the container itself to change the behavior of the system. Okay? Then I'm going to call my block manager. I'm going to get my block manager. I'm going to create an instance of the block. I'm going to call build, and then I'm going to assert that what it returns is empty, right? Because that's what I told it to do. And then I want to test that I have a non-empty block. So again, I'm setting up a mock response here on my mock client to set back the actual body that I expect. I get the instance of the block, and then I call the build method, and I assert that the render array that's returned has the elements that I'm expecting. All right, so what does that end up looking like? Again, I'm in the web directory. This looks just like the other command because we're still running the kernel test through PHPUnit. This time we're using test suite equals kernel, and we're passing in our group. And again, remember I said that this runs a little bit slower because it has to bootstrap Drupal and do all that stuff. Good. So that's all set. Any questions on the unit test and the kernel tests and how they differ?
Is kernel testing a simple test?
Kernel testing is not simple test. Kernel testing is PHPUnit. It's run through PHPUnit. The only thing that runs through simple test right now are the browser tests, and that will be removed in Drupal 9. There will be no more simple tests. If you've ever had the fun or the pain of trying to write simple tests in Drupal 6 or Drupal 7, I understand why people never wrote tests. I honest to God, I know why I avoided them. It didn't work half the time. It was horrible. It really is a pure joy to write tests in Drupal 8. It's simple. It's effective. But there are some problems. Okay? Unit tests are awesome because you're testing each individual method by itself. And that's really great. So you can tell that they tested the crap out of this locking door thing, but they forgot to test how it integrates with the part that it's locking. And again, you see with the kitchen drawers, great, those handles are awesome. The drawers work as they're supposed to, but when they were integrated together, not so good. And the urinals, an obvious example right there of not good integration tests. Okay, so in the testing world, we have this concept of the automated testing pyramid, where at the very bottom of your pyramid are the unit tests and the component tests. And they're the bottom because they're cheap, they're fast, they're simple to write. So you have lots and lots of those. In the middle, you have your acceptance tests. So these are your integration tests, your Behat tests, your browser tests, your JavaScript tests, and then you have at the very top you have the GUI tests. Those are also referred to as like end-to-end testing, where you're going soup to nuts from start to finish, the whole thing. That's the smallest part because those are the most expensive to write, and those are the most time-consuming. And then you have manual tests up in some cloud that hopefully floats away. Now, we can flip this into 3 pyramids that show the same sort of thing. So at the bottom where it says 5,000 plus, again, this illustrates the largest number of the tests that you should write are the unit tests because they're small and they run very quickly. In the middle, that runs in the tens of minutes, these are your more in line with the browser tests and the Behat tests. And then as you get up, you can see how it scales, right? You end up getting a measure of loss of investment. The more time you sink into something, the more time it takes to run. They're tough to maintain, so you get a decreasing return on investment. So really, the bottom 2 are where you should run and spend all of your time doing your tests. But it doesn't matter if you've got 5,000 plus unit tests. Before I came to Bioraf, we were writing all these unit tests, and the unit tests were beautiful. They did all sorts of great things, but we were still having problems. We were still having bugs, and the reason why is there were no integration tests. The unit tests looked like everything was passing and working great, but when you put them together, you'd come into situations that would cause failures. So there really should be a balance between how extensive your tests are and how many there are, and that middle ground is really your integration tests. Okay, so Drupal 8 calls these functional tests, and they're split up between browser tests and JavaScript tests. They're also known as UI tests. Different circles have different names for them. And again, they test the balance out between the expense of speed versus confidence. If you're spending all of your time just writing unit tests, you're lulled into a sense of false confidence that everything's working the way it should. So Drupal 8 supports the browser test and the JavaScript test, but there should be an asterisk next to the JavaScript test because they support it, but they don't really because you need an external piece in order to get them to run. And we'll talk about that. So specifically browser tests, they run in a fully installed Drupal environment. Again, just like the kernel tests, you have to declare all the modules that you need in order to satisfy your tests. And it uses an internal web browser behind the scenes to actually run the tests. These run even slower than the kernel tests because there's a bigger bootstrap to run. And JavaScript is not supported in this. So if your UI relies on JavaScript elements in order to achieve functionality, browser tests are not what you need. The way you write your tests, again, it should be very simple. Instead of going into source/unit or kernel, we put them in functional. Browser tests, again, they have a namespace that follows that path, and you should have a group annotation on your tests. How you run them is slightly different. You'll see here that in this particular case, I'm telling it to run the entire test class and all the methods in there. Because it's PHPUnit, I think you can still pass in the act group on the command line. And we'll see what that looks like. I keep forgetting I have to get out of presenter mode. Okay, so my functional test. How does this differ from the kernel test? This differs in the sense that because it's an integration test, I'm actually making a real live call out to my end service. Okay, so I'm setting up the modules explicitly that are required in order to run this test. I'm doing some setup, and you may need to. This is one of those gotchas. You may need to add this line to your test, or else you'll get PHPUnit can fail with some squawks about inconsistent config and things like that. I'm going to log in as the root user. I'm going to set my API key in the configuration, and I'm going to place the block. And by default, when you call Drupal place block within your your browser test, it puts it in the left sidebar. I could easily change this parameter and add in what region I want it to go in. But in this case, the default is just fine. So there's one thing that we're going to do here. We're going to test the HTML that's produced by here. So when I go to the front page, I want to make sure that I got a 200 status code, so we know everything's okay. I want to make sure that I've got a block here with this particular ID in the element. I get the page, and then I'm going to actually load that element, so this actually returns back an object, and I'm going to use that object to find the pieces that I want. So I know my block should have an h2 tag in it, and I want to make sure that the value of that h2 tag is not null. I want to make sure I actually have a real value. Same thing here, I want to get the image. I want to make sure that it has a specific class on the image, and then I want to get the description that's in the block, that the actual block content, and make sure that that's not null. So we'll go over here and we'll run this. Now here's an interesting thing that I just ran into. Like I said, my whole development environment got completely borked. And I managed to get it up and running, but lo and behold, Apache's running as a different user now than it was before. And so when I was running my unit tests, I was getting all these kind of directory fails type things. And the problem is that when you run your browser tests through PHPUnit, it actually executes as whichever user Apache is running. So I was executing the test as myself, and it was failing. So you actually have to run it as that's a gotcha. You have to run it as the user that Apache is running under. And so this is going to go ahead and run that test. And it's going to go and create a Drupal stuff in the test database that I had set up. And it's going to set up the modules that I asked it for. It's going to log in. It's going to set the API key. It's going to place the block. And then all of that content should just automatically be there. And lo and behold, everything works. And I suppose I should actually show you guys. And this isn't going to win any design awards. This is really, and I really mean this from the bottom of my heart, this code is really here just for demonstration purposes. Do not go and put this on the site someplace, for God's sakes, because there are so many things that are just wrong with what this code is doing. But basically, there's your ugly thumbnail image that doesn't fit and is the wrong size to actually be meaningful. And here's the data that's actually coming from NASA. So this is what the block actually looks like right now. So we were able to test. We were able to go and test that these things are here. I know by going into the inspector here that really is an H2 tag. And we know that there really is, within the content here, there really is an image that has the class that we're looking for. If I get past the contextual stuff, so there's the image, and you can see it's got the image style thumbnail, and so on and so forth. So when things go wrong, here's one of the problems with these browser tests. There's no debugger. There's no way to tell what the browser is actually seeing behind the scenes when you're running the test, right? So that makes debugging really, really, really tricky. You end up having to do a bunch of print statements. PHPUnit has a way to set up an output log and tell it to pass in this output printer where then you can log messages to that. But it is really, really tedious to write the browser tests. And for that reason, I don't recommend ever writing browser tests, unless for some reason somebody tells you must. The better alternative is Behat, and we'll get to that in a second. Okay, so the big brother to these tests are the JavaScript tests. As I said, the browser tests themselves have no way to interact with JavaScript whatsoever, and so that's why we have these JavaScript tests. They go in a functional JavaScript directory. So whereas the browser tests go in functional, these go in functional JavaScript. These tests require Phantom.js in order to run. So in order to run these things, you have to go and download and install Phantom.js, and you have to set it up to run Again, they use a full Drupal installation, and you can use this to fully test AJAX functionality, any kind of point-and-click stuff that you really need to do via JavaScript. There's no UI on this either. However, Phantom.js does have a debugger that you can go and debug things. So how do we do this? We go and we download Phantom.js. We set up we set up our Phantom.js. We run that as a daemon. You can run it in the background. We're going to tell it to ignore SSL stuff, set debug in true, and then we're going to actually go and run our test. Okay, so I've done all that for us. So this is in this particular console, I'm already running Phantom.js. Over in this console, we're going to run our functional JavaScript thing. And I can tell you, we can actually watch the debugger as it's going. And you can actually see that it's making calls out through Phantom.js and it's doing the things it needs to do. And then the tests are passing. What does the test actually look like? We're testing that the block exists. So we know that we've got our module enabled. We know that the block is there. We know that we want to make sure that the title is visible. That's something that we couldn't do on the browser test. We want to make sure that nothing is magically setting it to hidden or display none or something like that. And so on and so forth. And we can also do these great things like create screenshots of what the browser actually sees at the given time and pass it into a specific directory if you want. Okay. So again, there's no UI, there's no way to see what's going on whatsoever except at the very end when it tells you something broke. And Behat is the answer to all these problems. Okay, so Behat uses a library that then you have to pull in via Composer. The test language itself is human readable, which means that it is self-documenting. It's not like going through and looking at all of your mocks and all this other stuff to figure out what's going on. The Gherkin is really, really easy to read. It does run in a full browser, a local browser, and you can tell it what browser you want it to run in. So you can do cross-browser testing, which we're all doing, right, folks? Yeah, nice. And because it's a full browser that's running locally, you have access to all the debugging tools that you normally have in Chrome and Firefox. So this is how you pull it into your composer.json. Pull in the Behat extension, and then there are extensions to that, like table assert, like saying I expect a table with the following rows, or I expect a table with the following columns, things like that. So in order to run these things, you have to have a YAML config file, which tells Behat how to act. And then we go and we run our test, and the Behat executables in vendor bin Behat, and you pass in tags. The tags are like groups in the other examples that you've seen. Okay, so when I say that these things are human readable, I really meant that. So let's go see what that looks like. One thing that's interesting about the Behat test is they don't live with your module. They live outside in this features directory above the doc root. So there's a bootstrap directory where you can add your own features to what's called a feature context, and then you have your actual features. Why don't we, if we look at the behat.yaml file first, I'm really liking that pinch and drag thing. I didn't know that. It's just a YAML file. We tell it what context we want to run. So these are all the ones that come by default with the extension that you're including with your composer.json include. And then here's our specific feature context. We tell it what browser we want to run. I run all of mine in Chrome, what the base URL is. There's a whole bunch of different options that you can pass through here. Again, stuff for the API driver. Drupal has this whole driver that you can use to control what's happening. And you can set up your region maps and a whole bunch of other stuff. So this basically just controls the behavior of Behat. So a Behat test looks like this. Come on. Thank you. And I don't mean this to be a tutorial on how to write Behat tests again, but so at the very top here we've got these things up here, which these are like our tags. These are our groups, like in the other ones. So I've tagged this one for my particular module. If you tag this with @JavaScript, then Behat can go and capture screenshots and do all sorts of other cool things. So what this does, there's a background section, and I'm going to clearly state that the APOD module is enabled. So given it's enabled and that the following users exist in the system, and when I make those assertions, Behat will behind the scenes go set that up for me. Okay. Then I start writing scenarios. So a scenario has a description. So as a, copy and paste. So as an admin user, I can go and set up and configure my module. So given I'm logged in with as an administrator, I can go to this URL, I can fill in the text field for the API key, I can save the configuration, and I'm going to see this message that the configuration options have been saved. Okay, that's clear, human-readable set of expectations for the behavior. You can come back to this in a year, read the Behat test, and know exactly how this thing works. So checking the block is there. As a regular user, I can log in, I can go to the home page, and I should see my block. And I'm looking for the block with a div. There's lots of different ways you can write this. This is just a very simple example. I could have put in assertions here that I should see an image of the specific size, I should see content, all those kinds of things. And then we'll go and we'll run this command. And Behat tests are really fast too. Boom. If these were to fail, it would tell you where it failed and why it failed. It creates an output dump of the HTML that it was looking at, so you can see where it failed. You can load that in your browser. You can inspect the elements. You can do all of that, and you can also take a screenshot. So really, really powerful stuff here. So at Bioraft, we're writing kernel tests, unit tests, and Behat tests. We're not writing browser tests. We're not writing the JavaScript test because Behat really does them better. Okay, so tests can help drive development. This is called test-driven development. You don't have to do that, but here's one thing that you can do. This is something that we've started to do at Bioraft. Where we're given a card in Trello or in Jira, and it's got some requirements. When the developer gets that, the developer translates that into Gherkin and pastes that right in the card. You can just mark it right out. So as a user, when I go to this URL, I should see a table with all this kind of information. When I press this button, this should happen. And you can translate those requirements right into Gherkin. Now you've already got your test written. Now all you got to do is write the code to satisfy the tests. So it becomes a way of using the test to drive your development. You can even possibly train your feature owners who are writing the features to write in the language of Gherkin and save everybody a step. And it really provides that translation layer between developer speak and product speak. You can do the same thing kind of, sort of, with unit tests. I don't know how you guys develop, but oftentimes when I go to write a class, I'll think of the methods that I need first and I'll stub them in. And then I'll go and I'll write some unit tests. Or maybe I'll write the unit tests for the methods that I think ought to exist. Because then that helps remind me, oh, if I'm going to write this method over here and it has this dependency, I need to inject it somehow. Either through a setter or through the constructor or whatever. You can also add functionality and test concurrently. So let's say you're working on bug items. You fix the bug, you write a test to prove that it's fixed. Now those two things are done concurrently. You commit those both. They run through, say, Circle CI or Travis or whatever. Now your tests are being run automatically when you push your feature branch or whatever, and boom. Then you don't even have to remember to run the test. But I do, unless you really like getting build failed messages in Slack or whatever from whatever integration system you're running and having your coworkers see how much you suck at testing your stuff. I do recommend that you always run through your test before you push if you're doing any kind of continuous development, continuous integration. And At Bioraft, for our Drupal 8 stuff, we're using Git branches per feature. So whether that's a bug fix or a new feature, we have our own branches. We write our tests. Those, when the PR gets approved, they get merged to a QA branch, a sprint QA branch. All the tests get run there again. Now you know that everything that got merged in for that sprint is great. Merge it back into master, and then you can run the test again if you really want. But it really helps us to know when something is done. You finish your development, the tests are passing, you're good to go. I know we're running out of time here. So some gotchas. Unit tests are awesome, but because they're atomic, if you go and you make major rewrites to your code, you probably have to make major rewrites to your unit tests. Okay, the two are really tightly coupled. But again, because they're atomic, you get really, really good confidence that that particular method can be tested with complete confidence that what it's given in, it's going to be able to handle and spit out what you expect. Sir?
We've actually used it where when we're going to make a major refactor, like you were saying, you can do the test, or we rewrite the test first, so that way we know when we're done with the actual coding, go into your test pass.
So for the recording here, the suggestion from Eric at Acquia was that at Acquia, when they go and do a major refactor, they rewrite the unit test first and then change the behavior of the code to match the expectations of the test.
Yeah.
So that's a great example of test-driven development. For the kernel and browser tests, you have to explicitly enable your modules. Okay, so that's something. We talked about this. Schema can cause problems, and you sometimes have to call this a strict config schema. Traits are a problem, especially in unit tests. If you've got a method that's using the string translation trait, and you try to run your test, it will fail. So in your unit test, you actually have to call this, on the object that's under test, you have to call this set string translation method. And pass it in the get string translation stub. So that's something that Drupal provides for free. It has to do with the way that traits work in PHP. We talked about debugging in Phantom.js is not fun. Permissions, we talked about that. So for browser tests, you have to make sure that you're running the test as the same user that Apache is running. And here's a screenshot that shows that traits can be problems. That's what it looks like if you forget to set that up. Okay, so in summary, unit tests are for testing class methods, kernel tests are for testing APIs or when your classes have too many dependencies. Functional and behavioral tests are for testing web interfaces, and use Behat instead because it's awesome. Resources. Sir?
Oh, I don't know.
Okay. Resources. Drupal.org has great documentation on PHPUnit, and it's getting better every day. There are specific things for writing the browser test and the JavaScript tests. There are tons of blogs about Behat tests. And then there's the theoretical blog posts about what kinds of tests to write, how, why, when. And then Lullabot has a really good overview of testing in Drupal 8. And don't forget that simple test is going away. So if you've developed a reliance on simple test or you're really, really good at simple test, pretty soon it won't be there. So start learning PHPUnit because it's better. Questions?
Two quick questions. One, you've got a full project, you've got a bunch of kernel tests, browser tests, whatever. How long does that take? I know unit tests are generally pretty quick, but how long does it take if you have a whole suite?
So the question is, if you've got a whole project and you've got lots and lots of tests, how long does that take to run them? So what we do at Bioraft is we don't run any of the core or contrib module tests. So it really depends on how many custom modules you have and how many tests you've written. Right now, our circle tests take under 5 minutes to run, and that's all the unit test, the kernel test, and the Behat test together.
And I read Phantom.js is no longer maintained. Have you looked at alternatives?
Yeah, so the question is Phantom.js may no longer be maintained. There is a ticket on D.O to replace Phantom.js with, I think, Nightwatch, which is something similar. I've never played with it because, I see more value in the Behat tests than I do with the JavaScript tests. But I may be wrong on this. I think Drupal.org doesn't support running the Behat tests. I don't think they have any built-in support for that, so not yet. So if you really want complete functionality, complete code coverage for, let's say, a contrib module that is useful, people like it, and you really want to do that, then you're kind of forced to use the browser tests and the JavaScript tests there. Sir?
So when you're running the Behat tests, what are they running against? I mean, it was fast, so it wasn't
Right.
installing a new instance. Do you have two databases? Do you have a different database prefix?
Right. So the question is, how does the Behat stuff actually run? So we go back to our behat.yaml, and we tell it what base URL. So you can set that up to be a test instance. So when we run this in Circle, Circle creates a brand new instance on every single commit. So you make a commit, and it wipes out the previous instance, creates a brand new one, and that in our BioRaf stuff, that base URL is dynamically generated. You can also run this off of PHP. PHP has its own web server built in, or PHP 7 has its own web server built in. So you can pass that up, so you start that up automatically. And then, however, that instance, Drupal instance, is connected to the database. Behind the scenes, Behat uses it's called a Drupal driver, and that's what you're actually pulling in through your composer.json. So if we go into if we go into vendor and we go into DaVinci Behat extension, and we look at the source there, there are a whole bunch of things that are happening, and it's using the Mink drivers or GAT drivers or whatever in order to execute those tests. And so it's really the Drupal API that goes and provides that integration. We talked about earlier about how you can set up your own things. So for example, in this particular setup, if I can get this thing to expand. So I have my own feature context here that's extending the raw Drupal context that comes with that driver library. And I'm setting up my own support here, my own step that the module is enabled, and it's using the Drupal driver to go and enable a given module. So you can do all sorts of things like that. In BioRaf, we've had to do a ton of things like that, especially around the table assertion stuff, which tends to be a little bit flaky. If you use the one that I referenced earlier in the slides, it's very particular. If you say, I expect a table with this row, and you actually have more rows than that, it'll cause a failure. Things like that, which can be really annoying. You really want to try to avoid spurious failures like that wherever possible.
Does Behat with basis completely everything that something like Selenium does?
Yeah, so the question is, does Behat do pretty much what Selenium does? They're very similar. Selenium tests are very similar to the Behat tests, although these are more tightly coupled with Drupal on the back end, programmatically on the PHP side. So we're actually, believe it or not, we're actually running Behat tests against much older versions of Drupal, not just Drupal 8, but much older.
I would say that one thing with Behat too is spend some time learning the syntax. Because if you change the syntax a little bit, you end up, it says you need to write your own custom
step, right?
Whereas if you use something that's already existing, it's much easier.
The statement there is that if you're not careful with your assertions in your Behat code, then Behat won't be able to find it. So one of the things that I do, I write in PHP Storm, and PHP Storm often recognizes what I'm doing here. There's a Behat plugin, and it knows what steps are supported, and also has code completion, and I should. And it has a whole bunch of the different assertions different steps I can put in there. So it's really cool to have that. It really helps you write your tests. Unless, if you're not like me and you don't know every single step that's ever been declared, and you need a little bit of help because you're a special snowflake, PHP Storm makes you feel like a rock star. Eric.
One last thing, if you write things other than Drupal, note that Drupal 8 still is using a version of PHPUnit that's a couple of years out of date. So if you're writing other tests for other things, you may have different versions. There are core issues to try and get them updated.
Yeah, think I saw that was slated for 8.5 to upgrade to the PHPUnit 4 or something, or 6 or whatever.
6 is the latest, yeah.
6 is the latest. Yeah, obviously that's a big task because they have to go
right
and
now, so.
they have to go and fix all the broken core tests, and then all the contrib modules have to upgrade.
Well, I think the base issue is in review right now, so that's good.
Cool.
And passing tests, so.
That's awesome. Another thing to mention, speaking of unit tests are very hard to test static classes and static methods. So if that tends to be your code style, you're going to have a hard time writing unit tests. So try not to do that. Cool. Any other questions? We are right on time. 1 minute over. Awesome job. Thank you all for coming.